Hello students, welcome back to a new mathematics program for grade 7. Today we are going to talk about the chapter sets. This video is the third and last part of the chapter sets. Remember that in the first part we talked about the definition, importance of sets, types of sets, finite and infinite sets. Then in the second part we talked about elements of a set, subsets, equal sets, cardinal number of a set, empty or null sets, notations denoting them. Now in this third video we are going to talk about the universal set, the complement of a set, union and intersection of sets, and finally we are going to talk about Venn diagrams. Well, let's start with the universal set. The universal set consists of all elements to be considered in a particular situation. We use this symbol to represent the universal set. For example, if the universal set equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Then the set A consists of all even numbers. So we write A is equal to 2, 4, 6, 8 and 10. But we all know that even numbers does not stop at 10. But here the universal set restricts us to numbers from 1 to 10. That is, the set A is a subset of the universal set. We need to take elements from the universal set. Okay, so we must not forget that we cannot go beyond the universal set. Let's take another example. If the universal set consists of numbers from 3 to 15, set A is the set of all odd numbers, set B factors of 12, set C multiples of 3, and set D square numbers. What are you going to write for the set A if I ask you to list the elements of the set A? Yes, the set A will consist of the following elements: 3, 5, 7, 9, 11, 13 and 15. We cannot go beyond the universal set. Same for factors of 12, multiples of 3. For set D, can you tell me what are the square numbers found in the universal set? Yes, only 4 and 9. Okay, so you must always remember that we cannot use elements which are not in the universal set in a particular problem. Like in this one, we were restricted to numbers from 3 to 15. Now let's talk about complement of a set. Consider the set A. The set of all elements which are not found in A but in universal set is called the complement set of A. In set notation, we write it as A dash. For example, if we have the universal set consisting of the elements from 1 to 10, 1, 2, 3, 4, 5 up to 10, if the set A consists of the elements 2, 4, 5, 6, 8 and 9, the complement set of A, written as A dash, is equal to 1, 3, 7, 8 and 10. In other words, set A dash consists of elements that are missing in A compared to the universal set. A dash consists of all elements that are not in the set A but which are found in the universal set. Let's talk now about union sets. The union of two sets is the set of all elements but without repetition. We use this symbol to represent the union of two sets. Consider the sets A, B and C. Okay, these are the three sets. The set A union B equal to all the elements from A and from B, as you can see here, but without repetition. You can see element 5 and 6 in both set A and B. While taking them together, the elements of set A and B, we have not taken 5 and 6 twice. It means that we have taken all the elements without repetition. What about A union C? Think about it. We are going to take all the elements from the set A and the elements from the set C, but we are not going to repeat elements. That is, we are not going to write an element twice. Like you can see in set A we have the element 3, again we have element 3 in set C, but while writing A union C, we must write the number 3 only once. So this is the union set of A and C. Let's talk about the intersection sets. The intersection of two sets is the set of all common elements. We use this symbol to represent the intersection of two sets. Again, consider these three sets. I'm going to find the intersection set of A and B. As the definition above, we have said that we need to find the common elements. So A intersection B is equal to 5 and 6 because we have the element 5 and 6 in both the set A and the set B. What about A intersection C? Look at these two sets, set A and the set C. Find out the common elements. The common elements are 3 and 5. Now look at this example where we have the universal set, set A, set B. If I want to list the elements in A intersection B, I will have 5 and 6. A union B, I'm going to take all the elements from A and from B, remembering that we need not write one element more than once. That is, we must take all the elements from A and B without repeating any element. Earlier we talked about complement of a set. So A dash is equal to 7, 8, 9 and 10 because we don't have this element in A, but we have them in the universal set. We also talk about number of elements. If we want to know the number of elements in A dash, we just need to count the number of elements in A dash. Here we have 4. We talk about A union B, but now if I ask you A union B dash, look at the set A union B. A union B dash means the complement set of A union B. Looking at the set A union B, then you look at the universal set. You will see that number 10 is missing in A union B compared to the universal set. So the set A union B dash equal to 10. Venn diagrams. A Venn diagram consists of separate or overlapping circles placed inside a rectangle. In fact, a Venn diagram is a graphical representation of sets. Each circle contains all the elements of a set. And the rectangle represents the universal set. Like this rectangle represents the universal set. This circle will represent A and this one will represent the set B. However, we can have different situations. Like you can see here, there are 3 Venn diagrams. In the first one, you will see 2 circles intersecting. That is, here we have A intersection B equal to null set. Remember, earlier we talked about null set. If A intersection B is not equal to null set, that is, we have elements in common. So if we have elements in common, while drawing a Venn diagram, the 2 sets must intersect each other to find a common space. In the second diagram, you will see A intersection B equal to null set. That is, we do not have any elements in common. If we do not have any elements in common, we're going to draw the circles separately. These two sets are also called disjoint sets. In the third Venn diagram, you will see one small circle inside a bigger one. We talk about it while talking about subsets. The set A is a subset of set B. A is the smaller one and B is the larger one. So A is a subset of B. While drawing the Venn diagram, we must draw it like a big circle and a small one inside it, representing the subset. Now let's have a look at the different regions in a Venn diagram. I'm going to take two sets that have common elements. So common elements mean intersection set. That space, which is found in both set A and B, represent A intersection B. If I want to know where is A union B on a Venn diagram, the shaded part here represent A union B. Complement of a set. We mentioned earlier that complement of a set means elements that are not in A but in the universal set. This is our universal set. This is set A. This is set B. The complement set of A means element outside A. So all the regions that are outside A is called the complement set of A. The shaded part here represents the region A dash. Similarly for B dash, the region which is outside B is B dash. We can also use Venn diagram to list elements. In fact, a Venn diagram helps us to list elements of different sets. Take this example. We have the universal set from 1 to 10, set A and set B. First, we must know how to draw the Venn diagram. You can see that we have element 5 and 6 which are common to both A and B. So, while drawing the Venn diagram, we need to draw two intersecting circles because we have common elements. First, we start with placing the common elements. 4, 5, and 6 are the common elements. After writing 4, 5, and 6, you are left with numbers 1, 2, and 3, which are elements of the set A. So you write the elements of the set A. Concerning B, you have already written 4, 5, and 6. So 7, 8, and 9 are the other elements of the set B. Looking at the universal set, you will see that number 10 is missing in both A and B, simply because they are not elements of A and B. So we write 10 outside A and B. Number 10 forms part of the universal set, but not in A and in B. If I want A intersection B, I have shown you where is the region representing A intersection B. A intersection B is the region which is found in both A and B, which is in the middle. So A intersection B equal to 4, 5, and 6. Now talking about A union B. A union B means take all the elements in A and B. Here you can see the elements in A and B, and you will also see that there is no repetition of numbers. So you just have to take the numbers that are found in A and in B. This is the union set of A and B. A dash means all the elements that are outside A. Just have a look at all the numbers that are outside the circle representing A. These elements are elements of A dash, that is complement set of A. Same for B dash. All the elements that are found outside B are the elements of B dash. Now, if you want to have A union B dash, A union B means inside A and B, A union B dash. Look at the Venn diagram. Look at the number which is found outside both A and B. It is the number 10. So A union B dash equal to 10. Let's have a look at another Venn diagram. This is a universal set, set A and set B. Here we do not have common elements. So while drawing the Venn diagram, we must draw them separately. We call A and B disjoint sets, so we draw them separately. Now we just have to fill in the elements. Okay, 5, 6, and 10 are the elements that are neither found in A nor B. So we write them outside the circles but inside the rectangle. Same as for the first example, you can find A intersection B. There is no elements common, so A intersection B is empty set, or you can use null set. A union B, you take all the elements from A and B. A dash, all the elements outside A. B dash, all the elements that are found outside B. A union B dash, outside both circles, we have 5, 6, and 10. Look at the third type of Venn diagram, where we have two sets where one is a subset of the other. Here you can see that B is a subset of A. So while drawing the Venn diagram, you must place one circle inside the other. The smaller one is the subset, so we write these elements first. While writing 2, 3, 4, and 5 inside set B, it means that we have already written 2, 4, 3, and 5 inside the circle A. These are the common elements to both A and B. We don't need to write them again. So the other numbers, the other elements of A are 1, 7, 6, and 8. The numbers 9 and 10 do not form part of the set A or the set B. So we write them outside these circles, but inside the rectangle representing the universal set. Here, if we want A intersection B, these are 2, 3, 4, and 5, because these elements form part of two sets. This is A union B. This is A dash. A dash means outside A. We have number 9 and 10. But concerning B dash, outside the set B. Outside the set B, we have 1, 6, 7, 8, 9, and 10. Here, A union B dash, outside both circles, we have the numbers 9 and 10. So you can see that while listing the elements of a set, if we make use of a Venn diagram and we know what each region represents, it is quite easy to know the elements of different sets. The Venn diagram can also be used to represent particular regions. In the following slides, I'm going to show you how to shade a particular region. The first one, you are asked to show the region that represents A dash intersection B. So first, you draw your Venn diagram, you shade A dash. Then you shade B, because you want to find the region representing A dash intersection B. Now look at the first two Venn diagrams. The first one we have shaded A dash and the second one B. Intersection means common. Now find the common region in both Venn diagrams. You will see that in the third Venn diagram, it is the answer, the region that is found in both A dash and B. So this region represents A dash intersection B. This is the second example. Here we want to shade A dash union B dash. So first, we have shaded A dash. In the second one, we have shaded B dash, the region outside A and the region outside B. Here we are looking for union of these two sets. That is, we need to take all the region that are shaded in both diagrams. So in the third one, you will see the shaded part represent A union B dash. It is only the middle part that is unshaded, because the middle part is neither shaded in the first diagram nor in the second one. So this is the region representing A dash union B dash. Third example, here we have A dash intersection B dash. The region that is outside A and outside B at the same time. In the first diagram, we have shaded A dash, in the second one, B dash. Looking at these two diagrams, we'll see that we have A dash intersection B dash, the common region to both Venn diagrams here. This is A dash intersection B dash. So students, I am now giving you some exercises for practice. This is the first exercise. Now you can make use of a Venn diagram, or if you can list the elements directly, it's up to you. But if you use a Venn diagram, you will find it perhaps easier. Here you are given a Venn diagram. You are asked to shade A dash union B. The second one, you must copy the Venn diagram first, then you find the region A intersection B dash. So students, in this video, we have discussed about the universal set, complement of a set, union and intersection of two sets, the Venn diagram. We have also located specific regions on Venn diagrams. So students, if you want to have more information about the chapter sets, these are some links that you can refer. Students, this program ends here. This is the third and last part of the chapter sets. So see you soon for some other chapters on mathematics for grade 7. Till then, goodbye.